Okay, let's watch a little video about roots. Roots today of roots of numbers, specifically square roots. Down the road, later on this week, we're going to be talking about cubed roots, fourth roots, fifth roots. But today we are going to focus only on square roots. And we've done a lot with square roots when we were talking about the Pythagorean theorem in geometry. And just over the course of your last several years, you have looked at square roots of numbers. And I don't think that there's anyone in this class that doesn't know that the square root of 4 is 2. Why? Because 2 squared is 4. And we're going to go into the definition of a root down the road. What I want to tell you today is that we want to make sure that we know what the radical symbol is. The radical symbol is the symbol there in green. And you see this little 2 here. Square roots are so prevalent that we really don't write the little 2 on there. And you're going to see down the road later on this week that that little symbol is going to be important when we talk about cube roots and fourth roots. But for right now, when you see this symbol right here, and there's not a number, a 2 means there, and that means square root. So today in this video, we're only going to look at square roots. And we have the radical symbol, where A is called the radicand. And we're going to need to know that vocabulary word, radicand. So A is the radicand, and the green symbol is called the radical symbol. Okay, so let's go to the next slide. The next slide tells us what a simplified square root is. So a simplified square root will have no perfect squares in the radicand. Perfect square factors, that is. Perfect square factors in the radicand. And a simplified square root will have no radical symbols in the denominator. So let's just pause that for a moment. Let that process. And now let's do a couple examples. Okay? Well, before we do those examples, we need to know a couple laws, couple radical laws. These are 2 radical laws that we're going to use down the road to simplify cube roots, square roots, fourth roots, and all those roots that we're going to talk about down the road. But today we're only talking about square roots. And so law number 1 is the square root of A times B is the square root of A times the square root of B. Square root of A times B is the square root of A times square root of B. Law number 2 is the square root of the fraction AB is equal to the square root of A over the square root of B. Get out of there. And it's going to be, this is not really a note, this is just something that we're going to need to know down the road, that square root of A times square root of A is square root of A squared, which is A. So, like if I had the square root of 3 here, times the square root of 3, that's going to be the square root of 9, which is 3. But if I see this right here, you can just go to 3. An example using that would be the square root of x times the square root of x is just x. Square root of x times square root of x is indeed square root of x squared. Again, that's equal to x. And we're going to do some variables in this video as well, some square roots with variables. So let's cut to the chase and look at some examples. Here I have the square root of 8. This is not simplified because we see that this number 8, the radicand, has a factor that's a perfect square. So therefore, I can write that as the square root of 4 times the square root of 2, because 8 is 4 times 2. Hey, what's the square root of 4 is 2. So this is going to be 2 square root of 2. Now this is simplified because 2 has no perfect square factors. So therefore, square root of 8, which is not simplified, is equal to 2 square root of 2. Let's look at the square root of 48. Is it simplified? I don't think it is. And what I want to do is look at the factors of 48 that are perfect squares. Oh, right off, and some people can see this right off. You can take a 4 out of that if you want, but hey, you can take a 16 out of that. 48 is the same as 16 times 3. Therefore, the square root of 48 is the square root of 16 times the square root of 3. The square root of 16 is 4 times the square root of 3. And I notice that 3 has no perfect square factors. Therefore, the square root of 48, which is not simplified, is equal to 4 times the square root of 3. Now I have a radical expression that was not simplified. Now it is simplified. Square root expression. Square root of 48 is 4 square root of 3. How about square root of 75? Again, we should right off the get-go see that 75 is 25 times 3. Therefore, the square root of 75 is the square root of 25 times the square root of 3, which is 5 square root of 3. And what do I have? I have the square root of 75 is equal to 5 times the square root of 3. Simplified version, not simplified version. Okay? Hey, what about this? It looks simplified, but it's not, because I noticed that one property that I have, the square root of fraction is the square root of 1 over the square root of 2. The square root of 1 I know is 1, so now I have 1 over the square root of 2. This is not simplified because I have a radical symbol in the denominator. How do I get that radical symbol out of the denominator? Well, I'm going to multiply this rascal by 1. 1 in the form of square root of 2 over square root of 2. Now I'm going to look at the top, multiplying straight across. 1 times square root of 2 is square root of 2. And square root of 2 times square root of 2 is 2. So therefore, the square root of 1/2 simplified is the square root of 2 over 2. This can be a challenge. This is the key thing here, is to take this, write it as a numerator over denominator, and then this multiplication by 1 is the key to simplifying that radical expression. Okie dokie. Now I have the square root of 3 over 4, and I'm also going to use that property that says that, hey, this is going to be the square root of 3 over the square root of 4, and we know what the square root of 4 is, 2. And now this is simplified because I have no radical symbols in the denominator, and the radicand of the square root has no perfect square factors. So the square root of 3/4 simplified is going to be the square root of 3 over 2. Let's do a couple now examples with some variables. So let's look at this guy right here. Let's look at the square root of x to the 5th. Oh, darn. Not sure if you've seen anything like this, but this is going to be pretty easy. There's a couple ways to approach this. We're going to use laws of exponents, and we could just do this. This could be the square root of x squared times the square root of x squared times the square root of x, because x squared times x squared times x is equal to x to the 5th. Well, what do I know the square root of x squared is? Get out of there. X, the square root of x squared is x. I still have a square root of x, and I know that x times x is x squared. So this is going to be x squared square root of x. Therefore, I have the square root of x to the 5th is equal to x squared times the square root of x. Okay? The other way that I could have done that, I could have said, hey, you know what? The square root of x to the 5th is equal to the square root of x squared times the square root of x. Well, what's the square root of x squared squared? Is x squared square root of x. Either way, you're going to get the same answer. Some people can immediately go to here I will tell you, honestly, tell you that most students like this method here. Let's do another example. Let's go to a new page, and let's look at the square root of 18x cubed y squared. Oh, golly gee, it looks like a lot's going on there, and it looks like that might be difficult, but I don't think so. So what I'm going to do is take the radicand and just split it up into perfect squares. Well, 18 I know is 9 times 2. X squared is x squared times x, silly, times x squared. So look what I'm going to do. I'm going to take that property. I'm going to write this as the square root of 9 times the square root of 2 times the square root of x squared times the square root of x times the square root of y squared. And now I'm going to simplify all the square roots that I can. I know the square root of 9 is 3. This stays the square root of 2. I know the square root of x squared is x. This stays the square root of x, and I know the square root of y squared is y. So now I'm going to simplify this, write this appropriately, and the way I would want to write that is 3x y times the square root of 2x. So I have 3 times x times y goes here, and I have square root of 2 times square root of x is square root of 2x. So that's just a brief little video over square root functions. And I'm going to zoom out here and view each page. Whoopsie. So you get an idea. First thing we talked about was square roots. Radical symbol is the radicand. Come back to this page. This told us what a simplified square root was. And it not only told us what a simplified square root was, it gave us properties to simplify square roots. And then we talked about this process, square root of a times square root of a is a. And then all we did on the next 2 slides was some nice examples. Keep in mind you can pause that video, and that should help you with today's IXLs. All right, I'll see you soon.